Ever notice how an ice cube floats in your drink instead of sinking? That's not just a party trick, it's a scientific oddity. Most solids sink in their own liquid, but not ice. Water breaks the rules. When most things freeze, their molecules pack tighter and get denser. But water's molecules actually spread out. This makes ice less dense than liquid water, so it floats. It's a tiny rebellion happening in your glass, and it's crucial for life on Earth. Why does water do this? It all comes down to the unique shape of its molecules and how they connect. Let's uncover the secret behind water's floating act. Get ready to dive into the weird world of H2O, where getting colder means getting lighter. Science is about to get cool, literally. Everything is made of molecules, and waters are shaped like Mickey Mouse. One big oxygen, two little hydrogens. These molecules act like tiny magnets, zipping around and forming quick connections called hydrogen bonds. Imagine a wild dance party. Everyone's moving, bumping, and briefly holding hands before switching partners. In liquid water, molecules are close but always moving, making water dense and able to flow. The special shape of water molecules means they don't pack together like marbles. Instead, their positive and negative ends attract, setting the stage for water's freezing trick. As the temperature drops, the dance slows down. The way these molecules arrange themselves is about to change everything. The dance party is ending and a new structure is about to form. Let's see what happens when water freezes. As water cools, its molecules slow down and start holding on to each other longer. Near freezing, they lock into a specific pattern, a six-sided hexagonal crystal lattice. Each molecule connects with four others, creating a beautiful open structure full of empty space. Think of it like building a snowflake, organized, spacious, and strong. This crystal structure takes up more room than the jumbled liquid, making ice expand. So freezing isn't just about getting cold, it's about building a bigger, lighter structure. The molecules stop their chaotic dance and form a perfect repeating pattern. This expansion is why ice floats. It's all in the unique hexagonal shape of frozen water. That's the secret behind the great ice cube escape. Here's the key. Density is how much stuff fits in a space. Ice's molecules are more spread out than in liquid water, making it less dense. Imagine packing shirts tightly in a backpack, liquid water, versus spreading them out in a big suitcase, ice. Same number of shirts, but the suitcase takes up more space, just like ice. Because ice is less dense, it floats on water. It's a simple rule: less dense things float, denser things sink. This is the opposite of most substances, where solids are denser than liquids. Water's weirdness is its superpower. The floating ice cube isn't magic, it's science. And this one fact changes everything for life on Earth. If ice sank, lakes would freeze solid from the bottom up, killing all aquatic life. But because ice floats, it forms a protective layer on top, insulating the water below and letting life survive winter. The same happens in our oceans. Floating ice caps reflect sunlight, helping regulate Earth's temperature. If ice didn't float, our planet would be much hotter, and ecosystems would collapse. So, a floating ice cube is more than a drink cooler. It's a planetary lifesaver. Next time you see ice in your glass, remember, it's a tiny hero keeping our world in balance. Science is everywhere, from your kitchen to the poles. Stay curious, keep exploring, and appreciate the wonders of water. Because science is awesome.